Next example is solve the LPP by using simplex method. So before that one remark is if all entries in key column or pivot column are negative. Okay, all entries of key column or pivot column are negative, then we get a unbounded solution. This is very important remark. We get a unbounded solution. That is in suppose that this is a key column. Suppose this is any suppose that key column, then suppose that x2 is key column and all entries of x2 are negative, then we say that the given LPP has a unbounded solution, because all ratios are negative, so no finding the key row. Okay, so therefore given LPP has a unbounded solution. That is, if all entries in key column or pivot column are negative, then we get a unbounded solution. Okay, that, and this is first. If Zj minus Cj is equal to 0 for non-basic variable. Okay, if Zj minus Cj is equal to 0 for non-basic variable in the optimal table or simplex table, then we get a alternative solution. We get alternative solution. Otherwise we get alternative solution when Zj minus Cj for non-basic variable in the optimal table, then we get alternative solution. Otherwise there is a no alternative optimal solution. Otherwise there is a no alternative optimal solution. Okay, so this is two remarks. Okay, then next example is so maximum Z is equal to 4x1 plus 4x2 subject to 2x1 plus 7x2 is less equal 21 and 7x1 plus 2x2 is less equal 21. This is also less equal 21. Okay, and x1 and x2 are greater equal 0. So solution of this is firstly all objective function is maximum type, all b's are greater than 0, that is non negative. So directly we write the introducing slack variable. Okay, introducing slack variable, add two slack variable. Okay, and put their cost in objective function is 0. Okay, therefore maximum Z is equal to 4x1 plus 4x2 plus 0s1 plus 0s2 subject to 2x1 plus 7x2 plus s1 is equal to 21, and 7x1 plus 2x2 plus s2 is equal to 21, and x1, x2, s1 and s2 are greater or equal 0. So we have to find the zj minus, we have to calculate zj minus cj. Okay, so draw simplex table. Here cb, then yb, cb, yb, xb, x1, x2, s1 and s2. So upper side coefficient of z, coefficient in z. So the coefficients are 4, 4, 0, 0. In firstly write the all slack variable in basic column. So s1 and s2 are here slack variables, so we write in basic variable. Their cost is in objective function is 0, so their value is RHS of 21, and then next coefficient of constraints of x1, x2, s1, s2. So for first constraint, coefficient of x1 is 2, then coefficient of x2 in first constraint is 7, then 1, 0. Okay, then 7, 2, 0, 1. Okay, we have to calculate zj minus cj. Zj minus cj we have to calculate by using summation of cbxbi minus xi, that is this subtract this upper side of coefficients in so summation of cbxb is 0, cbxbi or xi. Okay, 0 into 2, 0, 0 into 7 is 0. Here minus 4, here also minus 4, then 0, 0. So how to choosing most negative, how to choosing here? Choose any one of the in this. Okay, suppose we choosing this is most negative, then we have to find the ratios. How to find ratio? xb divided by x1, then we have to find the xb divided by x1. 21 divided by 2 we get 10.5, and then 21 divided by 7 we get 3 is the smallest element. Okay, and therefore this is key column, and this is key row. So therefore leading element is 7. Okay, leading element is 7, and therefore leading element converting by unity by dividing its column, and leave x1 in s2 and introduce x1 and s2 is leaving in basic variable. We get 7 is leading element. So to convert leading element into unity by dividing leading element itself, and making all other element in its column to 0, okay, and introduce x1 variable in basic and leave in basic variable, leave s2 in yb. Okay, so therefore cb, yb, xb. Okay, then x1, x2, s1, s2 basic variables are s1 and x2, s2 by x1. So their coefficients are 0 in objective function, and x1 has coefficient in objective function is 4. Okay, so we have to dividing here 21 by 7. 21 by 7 is 3, 7 by 7 is 1, 2 by 7, 0, 1 by 7. So here use operation is operation here. Operation is R1 minus 2R2, R1 minus 2R2. Okay, so 21 minus 6, 21 minus 6 is equal to 15. Then 2 minus 2, 0. This is 2 minus 2 into 1 is equal to 0. Then 7 minus 4 by 7. 7 minus 4 by 7 means 45 divided by 7. Okay. 7 minus 4 by 7. 7 minus 4 by 7 is get 45 by 7. Then 1 minus 0 is 1 and 1 minus 2 by 7 is 2 by 7. Okay, and so now we have to calculate again Zj minus Cj. Zj minus Cj is equal to, here coefficient in Z, their coefficients are 4, 4, 0 and 0 in objective function. This is Zj or Cj also called as. Okay, so here 4 minus 4, 0. Then 8 by 7 minus 4, 8 by, this is 0 plus 8 by 7, 4 into 2 by 7 is 8 by 7, 8 by 7 minus 4, 8 by 7 minus 4 is minus 8 by 7 minus 4, 28 means minus 20 by 7. Okay, this is minus 20 by 7. Then next is 0, because 0 into 1 plus 4 into 0 is 0, minus 0, 0. Then 4 by 7. So this is a most negative. So then find the ratios. Ratios is xb divided by x2. Xb divided by x2 we get 15 divided by 45 divided by 7. Okay, 15 divided by 45 by 7 we get 7 by 3 answer. Okay, so similarly here 21 by 7. Okay, 3 divided by 2 by 7 we get 21 by 7. This is 3 and this is 2 point something. Okay, 2 point something, 2.33. Okay, therefore leading element is, this is leading element, this is key column and this is our key row, this is key row. Okay, so therefore leading element is 25 by 7. So draw the again next simplex table. Okay, and Zj minus Cj are 12. Sorry, summation of CBXB. Summation of CBXB is equal to 12, and this is Zj minus Cj. Here 45 by 7 is leading element, and so convert leading element into unity. Convert leading element into unity by dividing itself and making all write this all other as it is. Okay, making all in its column, making all other elements in its column, and lastly introduce x2 in YB and leave S1 in YB. Okay, replace S1 by x2. We get directly write this CB, next simplex column YB, XB, then x1, x2, S1, S2, coefficient in Z, that is objective function. Then replacing here x1 and x2. So dividing this column by 7 by 40, that is multiply this column by 7 by 40, we get x1 coefficient is 4 and x2 coefficient is 4. So multiplying this coefficient by thereby 7 upon 7 divided by 45. 7 divided by 45, their value is 7 by 3. Okay, 15 into 7 upon 45. Okay, then 7 by 3, 0 by 0 into something 0, 45 by 7 into 7 by 45, 1 into 7 by 45 is 7 by 45, 2 by 45, lastly 2 by 45, 2 by 7 into 7 upon 45. Okay, 7 get cancelled, 2 by 45. Okay, and making all other elements into 0. So operation is here operation is this is 2 by 7 and this is 1. Okay, so therefore operation is R2 minus 2 by 7 R1, R2 minus 2 by 7 R1. So therefore 3 minus, this is 3 minus 2 by 3. Okay, so here operation is, this is 3 minus 2 by 7 into R1 is 7 by 3. So 7 get cancelled, 3 minus 2 by 3, 9 minus 2, 7 by 3. Okay, this is also 7 by 3. Okay, then next is 1 minus 0, 1 as it is. Then lastly is 2 by 7 minus 2 by 7, 0. Then 0 minus 1 upon here 7 upon here 45. Okay, here 7 upon 45 here. So here next is S1 column is 0 minus 2 by 7 into 7 by 45, 7 get cancelled, 2 by minus 2 by 45 remaining. Okay, so then minus 2 by 45. Okay, or correct this operation, R2 column is 0 minus minus 2 by 7 get cancelled, minus 2 by 45. Okay, correct this. And then next is 1 by 7. This is 1 by 7, this is 1 by 7 minus 2 by 7 into 2 upon 45. Okay, so this operation is very large. 2 by 7 into R1 is 22 upon 27, sorry, 2 upon 45. Okay, 2 upon 45. Then 4 upon, this is very large, so their value is something here. Okay, so their value is something here. Calculate this in by using calc. Okay, so now we have to find the ZJ minus CJ. Okay, ZJ minus CJ is summation of CB minus EXI, because this is the last table for this, because all ZJ minus CJ are greater or equal 0. Their value is 4400. Okay, so here 4 minus 4 0, 4 into 0 plus 4 into 1 minus 4 into 1 4 minus 4 0. Similarly here also 0. Similarly here 7 upon 28 by 45 minus 8, 20 by here 20 by 45. And similarly here something very value, this is also greater than 0. Okay, suppose this, find this value and take this value. Suppose here 45 minus 4, 49 divided by, this is value is 49 divided by 7 into 2, this value. Okay, so this value is also greater or equal value. Okay, this value is also greater than value, because their summation minus this is also greater than. So therefore all ZJ minus CJ are greater or equal 0, and therefore optimal solution is, this is optimal solution is 4 into 7 by 3, 21 by 3 plus 21 by 3, we get, sorry, 28 by 3 plus 28 by 3, 56 by 3, 56 by 3. At what value? x1 is equal to, at x1 is equal to 7 by 3 and x2 is equal to 7 by 3. This is our optimal solution. Okay.